So, welcome to Unit 4. In this unit, we are going to learn new ways how to solve quadratic equations. So I think this video actually will have to be in two videos. Be sure to watch both of them completely. You will need every single example that I'm giving you to be able to do the completing the square stuff. So let's dive in. First of all, I'm going to ask you a lot of questions. Please pause, try and answer these questions first on your own. So, what is the standard form of a quadratic equation? Well, it is ax squared plus bx plus c equals 0. We've been dealing with that all semester long. So now, up until now, we have learned only one method for how to solve quadratic equations. Stop this and figure out which method that is, and then come back and see how close you are. So that method is the zero factor property, where we factor and set each factor equal to 0, and then solve. We've been doing that all semester long, okay? So in this unit now, in actually the second part of this unit, we will learn this second way to do this, and this is called the quadratic formula. We'll talk more about that in that section. And in this first section in this unit, we're going to learn the square root property method. Okay, so now here's the thing. When you have a quadratic equation, always try number one first. Try factoring it. That's always the easiest. If it does not factor, then do the quadratic formula. The only time that we want to use the square root property method is if it's in the proper format. The equation starts in the proper format. So, proper format is something like m squared equals 27, or a perfect square trinomial, m plus 3, the quantity squared, equals 27. If it looks like one of these, okay, then use the square root property method, okay? Otherwise, do not use the square root property method. Now, periodically, however, you are given a quadratic equation, okay, in standard or some kind of form, and you are told you have to use the square root property method, but it is not in the proper format already. So then we have a method for forcing it to go into the proper format called completing the square. Now, every teacher that I've ever worked with and every book I've ever seen says completing the square is a method all by itself. It is not. All completing the square does is force our equation into looking, well, actually like a perfect square trinomial. So like this one. And then we can use the square root property method. So that's what I'm going to be showing you right now, how to do this. So we want to look at all of these examples I'm going to give you so that you get a real clear understanding of how to do this. And one of the things that I do here is 2 steps at once. So be sure you're understanding how to do these 2 steps at once. So let's start. X squared minus 2x minus 10 equals 0. Okay, now we're going to assume with all of these examples that I'm going to show you that the directions have said you must use the square root property method to solve these. Okay, so I look at this. The only way I can get this to be a square root in the proper format to use a square root property is if it's already a perfect square trinomial. But if I look at this sign right here, I already know this is not a perfect square trinomial. So what I need to do is get rid of this -10 and open up that spot and put something else in there. So the way I get rid of this is to move it to the other side. And here's the two steps that I'm going to set up at the same time. First, I rewrite this, and remember, in a perfect square trinomial, this second sign is always positive. And then I've moved this guy over to the other side. Now, the thing is, if I put something new in this blank that I just put here that has never been there before, I just unbalanced my equation. So to keep my equation balanced, I have to do the same thing on the other side. That's something we all know, right? And the second step that I'm going to set up at the exact same time is getting it ready to put it into perfect square trinomial. Okay, so I do x, the quantity x, and minus comes from this guy always, whatever this is the same sign that's here, and the quantity squared, and then equals a blank. So make sure you have these two steps set up before you start. And now I'm going to use a different color here so we can see some things. So here's now what we do. Once we have these two steps set up, first thing I do is take whatever this is and only the number, not the sign, and I divide it by 2. Now listen carefully. I am not dividing this guy by 2 because he's 2. I'm dividing this guy by 2 because I divide everybody by 2. Whoever he is, I divide it by 2. And then that answer goes right here. Well, in this case, 2 divided by 2 is 1. Then the next thing I do is take this 1 and I square it. Okay, whatever this number is here, I square it, and that goes here in this blank. So we do this blank first, then this one, then this one, and then this one. 1, 2, 3, 4. Kind of looks like a funny shaped N. Okay. So once I got this guy, number 2 blank, then I just take and put that exact same number here, whatever it is. And then what I do here to fill in the 4th blank is add or subtract whatever's going on, add those all up, and then I get this. Now I'm going to rewrite this. We won't do that again, but I'm going to rewrite what I have here so that you can see it without all the extra stuff. And now you can see that this, what I have, has been forced to look exactly like this. So now it's in the proper format for us to use the square root property method. So let's go ahead and do that. Well, in order to get access to this x, I need to get rid of this square. Well, let's do the opposite of what we were doing in the last unit. I'm going to take the square root of that. Because remember, when the exponent and the index match, this will fall out as my answer, and now my x is free to do things with. But I have to remember, and this is critical, guys, because we're working with an even index, when I do the same thing on the other side, I have to put plus or minus. Okay? So, I put a square root on the left side, so I'm going to put a square root on the right side, but I have to put plus or minus. So now what I've got is x minus 1 equals plus or minus the square root of 11. And all I need to do now is get the x by itself. So I just need to add the 1 to the other side. Always push him up between the equals and the plus or minus, okay? That's where he belongs. And so now it's going to be x equals 1 plus or minus the square root of 11. Please write it like this, not like the book does. So now I've got two answers. X equals 1 plus the square root of 11 and x equals 1 minus the square root of 11. And of course, because I have a square here, I was looking for two answers. Again, please write it like this, not like the book does it. Okay, let's go on to our second example. I've got m squared minus 4m minus 32 equals 0. Right away, I look at this sign, I know this is not a perfect square trinomial. If it were, I'd just put that into a perfect square trinomial and go from there. I'm going to set up my two steps here. Okay, so getting ready to put something in this first blank. I'll do this again. In this first blank, to create a perfect square trinomial, but to keep my equation balanced, I've got to do the same thing on the other side. And then my second step is going to be starting to set up my perfect square trinomial. This is going to be our first blank, and then our fourth one. So, first of all, take this, excuse me, needs an M there. Take that, always positive, because we've already taken care of the signs. So 4 divided by 2 is 2. Then I take the 2 here and square it, put it up here, that's 4. Just take that 4 and put it over here, and now over here. Okay, added up the 32 plus the 4. Now I'm ready to use the square root property method. So I take the square root of the m minus 2 squared, and then plus or minus the square root of 36. And now I get m minus 2 equals plus or minus, and the square root of 36 is 6. Well, whenever I get a whole number over here, right away, split this into two different equations. One is with the positive 6, the other's with the negative 6, and now solve these. Add the 2 to both sides, and I get m equals 8. Add the 2 to both sides, and m equals 4. And so then I get m equals negative 4 or 8. Okay, so I've got 2 more examples, and then one for you to do, which I will do in the next video. So be sure to watch that one as well.